Welcome to Antiderivatives, otherwise known as Calc's attempt to mess you up. Okay, so I might have told you that antiderivatives calc will mess you up, but you have no idea what an antiderivative is to begin with. So, an antiderivative is basically just a big puzzle. It's just a backwards derivative. So, if you know your derivatives, you're going to be set for antiderivatives. And antiderivatives won't be the demise of your calc career. You'll be just fine as long as you know your derivatives. So, that being said, why don't we take a look at the basic power rule? Okay, so for the basic power rule, basically we'll have a basic formula. So cx to the n, and when we take the antiderivative, that turns into cx to the n plus 1 over n plus 1. So basically you're just taking and adding 1 to the exponent and then dividing by the new exponent. So let's look at an example. So you have 4x to the third. Add 1 to the exponent, so that's 4x to the fourth, and then divide by the new exponent. So 4x to the fourth over 4, which equals x to the fourth. And there you go. Okay, so now that you kind of get what an antiderivative is and what the basic power rule is, why don't we take a look at the notation that you'll be seeing more often. Okay, so for the notation, we're working on indefinite integrals. So what that means is that's going to be the general solution, and then plus c is always going to be at the end. So when you see that little like squiggly s thingy, that just means take the antiderivative. So then you'll have f of x, which is the function that you're trying to integrate, and then you'll have dx, which is just the derivative of x or whatever variable you have. So just do not forget the plus c. I forget it all the time, and it's my demise. Don't forget the plus c. Okay, so now that we've taken a look at the basic power rule and how to write it formally, why don't we take a look at some examples. So you have the table, it was on the Prezi, and it's also in your book if you need it. So let's look at some examples of constants, rewriting, and integrating a polynomial. Okay, so we're going to have a few examples. Let's start off with constant. So what we're looking at, so you got antiderivative of 3x to the fifth. Okay, so when there's a constant in the equation, we're going to kick it out to the outside, so it turns into 3 squiggly line x to the fifth. And then from there, you just take the antiderivative of x to the fifth, so x to the sixth over 6, and then at the very end, you multiply in that 3. Just so that way it's not so confusing for you. So wait till the end to put that constant back in there. Okay, so now we're going to take a peek at rewriting expressions before integrating. So right now we're looking at 1 over x to the third. So what we want to do in order to be able to integrate that is we're going to bring that exponent up to the top. And so how we do that is you just make the exponent negative and you can bring it up to the top, so that's taking the inverse of that function. So what we have is x to the negative third, and so from there you just normal antiderivative, x to the negative 2 over negative 2. Make sure you keep that negative in there when you're dividing. So at the end you got negative 1 over 2x squared, because you popped the x squared back down to the bottom, so it's not a negative anymore. Okay, so now we're going to try out a polynomial. So just remember, more than one, keep them dumb. Split it up into smaller antiderivatives so you know how to do the problem. So right now we have x to the third plus 3x squared plus x plus 1. What you want to do is split it up. So the antiderivative of x to the third plus the antiderivative of 3x squared plus the antiderivative of x plus the antiderivative of 1. So we just take the antiderivative of each, so you get x to the fourth over 4, and then x to the third, and then x squared over 2, and then x. And then at the very end you just add them all together again. So you just have a little bit smoother of an equation at the end, so you're not overwhelmed by all the numbers and all the x's. Once again, just try to make your life a little bit easier. Calc's pretty good like that, I guess. Okay, so I know you guys got those kind of down pretty okay, right? Of course you're not gonna have them perfect like that, but I want you to keep practicing those, keep working on those. But also let's look and have that, those are general solutions. So that's when you always have the plus c. So now we're looking at particular solutions. So that means when you're given a y and an x, you can plug them in and write one specific equation for that set of numbers. Okay, so this whole time we've been focusing on general solutions, which is everything with a plus c. But now we want to look at particular solutions. So you're still going to have to find the general solution, but you're actually going to put a value to c. So why don't we try one? So we have that f of x equals 8x to the third plus 5. And we know that the antiderivative of f of 1 equals negative 11. So all we're going to want to do is take the antiderivative of 8x to the third plus 5. So once again, we'll split it up into like the polynomials, just split it up, and we'll take the antiderivative of each one separately. So we'll have 8x to the fourth over 4, which equals 2x to the fourth, plus 5x, plus c. This is why we can't forget c. So from there, you just use the f of 1 equals negative 11. You plug that in. So we get 2 times 1 to the fourth plus 5 times 1 plus c equals negative 11. Solve for c. I hope if you can do derivatives and antiderivatives, you can solve for c. And then at the very end, you just plug that back into the equation. So we get 2x to the fourth plus 5x minus 4 equals capital F of x. So it's not so bad as long as you can take general solutions. Particular solutions is just plugging it in. Plug it in, plug it in. See? Simple as that. Thanks for hanging out with me. I hope you're a little bit clearer on what an antiderivative is and how to find one. So make sure to take a look at that Prezi, take a look at the book, because the book actually has like all the examples in it and everything. But I hope you learned something. Have fun with the rest of the year.